Hey Trick Class, let's look at this question from section 4.5. We're graphing now sines and cosines. So I'm going to go to Desmos real quick. Desmos is a big help in this section. But in this section, we've got y equals 5 sine 2x. And what we're being asked to do is come up with where are those key points, those basically like quadrant points from the unit circle for this function. So y equals 5 sine of 2x. So this is what this graph looks like. And if you can see, those are the 5 points that we're actually being asked to find. These are what I call the quarter period points. This is a period. A period is one whole path of the sine function, or sine wave, cosine wave, from its midline up, down across its midline, and back up to the midline. That's one period of sine. And so you can see here, we're doing it all between 0 and pi. That's one wave. And halfway between 0 and pi, we're back on the midline. That always happens with sine. And then halfway between those halves, which are the quarters, we end up at the peak and then down at the minimum, or the valley, I call it. And these are what I call the quarter period points, QPP, or what I refer to these as, QPP, quarter period points. All right, and they are the kind of, if you'll let me call them this, the start, the end, halfway, and then the quarters, like the first quarter and the third quarter. All right, if you've taken stats and you're really looking at that, that's a notation in stat. That's like a symbol for something in statistics. And this is like the 5-number summary in stats if you've taken stats before. In stats, it's the minimum, maximum, the median, the quarter, the first quarter, second quarter, quartile 1, quartile 3. But the way I think of it is we're being asked, where does the period start? Where does the period end? What's the halfway point? And then the location of the min and max. Right? And these steps that I'm taking from here to here, that's 1 step, that's 2 steps, that's 3 steps, and that's 4 steps. These are those quarter period points, 1, 2, 3, 4. Each one of these, like the whole thing, right? The whole thing is a period, and then each one is a quarter of a period. All right. So there's a bunch of ways to find them, but the easiest way, in my opinion, is to come up with what your period is. All right, and then start dividing in halves. I always think of it as like a halving problem. All right. So this is the basic sinusoid graph. I've got this available on our My Courses page. This is the sine function. It's in red. I've got it in red. Blue is the cosine function. But you can see sine right now. This is, A is 1. So 1 times sine of 1x minus 0 plus 0. So just the sine of x. Right? But you can see when I start moving these numbers, A, the value that's being multiplied by sine, stretches us vertically, but it doesn't change the period. The period stays the same no matter what I make the value of A. So A does not affect the period. Right? B does affect the period. B is what makes this thing get skinnier if B gets bigger and bigger and bigger, or it can get wider and wider depending on how small B gets close to 0. All right? So B is the thing that we're looking at that's going to determine our period. So in our problem, B is equal to 2. It's this number that's in front of x in that notation that we just saw right here. It's the number that's being multiplied by x, and in our case that's 2. And the way that this works is if this is 1, the period is 2 pi. But if it's not 1, then the period is 2 pi divided by that number, and technically the absolute value of that number. So 2 pi divided by 2 is just pi, and that is period of this function. Now this function does not move left or right. because there is no value being subtracted or added to that 2x. So what I mean by that is if we had like c, the number that I'm subtracting from that b times x, and let me make this 5 so we can make it match our function. Make this 2. So there's our function. But if this thing had a value being added or subtracted, notice it shifts left and right off of the origin. But when it's 0, then this thing touches the origin. The graph touches the origin. All right, so 0, 0 is a point on here. And again, I know 0, 0 is a point because there's nothing being added or subtracted, to this in a parentheses. So since this is not present and there's nothing being added afterwards, like a 2x, like a -4 or something, all we have is just the number times x, then the sign, and then the number after that. All right, so there's no shift left, right, up, or down, so that means the origin is on this graph. All right, so from there, I'm going to go to the end. So this is my first point in these 5 quarter period points. There's 5 of these. So that's the first point. The last point, the 5th point, will always come from adding a period. All right, so I add a period. The period is pi. You add that to the x coordinate. When you do that, you'll always land back on the midline. The first point for sine is on the midline. The last point is on the midline. So look at our graph. The first point is on the midline. Let me go back to this one that I drew that picture on. There's 0, 0. We added pi. We're back to where we started. So again, that's one period. I'm just going to graph that. Like nothing, I don't worry about anything else. I'm just looking at that part of this graph. So I start at the origin because I didn't go left, right, up, or down. I add a period. I add that to the x coordinate. I'm going to be back where I started. I'm back on the midline. So the y coordinate is the same. Okay. Now what do we do from there? We average these two x coordinates. If I average those together, I'll get pi 0 plus pi divided by 2 is pi over 2. And pi over 2, that number right in the middle, again, it's an x coordinate, again, we'll be back on the midline. So we start on the midline, and we add a period, we're on the midline, half a period, halfway between those two, averaging the two x coordinates. That's also a period. I'm sorry, that's also a midline intercept. We're crossing and in this case, the x-axis, but whatever our midline happens to be. All right, and then average those two x coordinates, the first one and the one in the middle, averaging these two, 0 plus pi over 2 divided by 2 ends up being pi over 4. That will be right there in the middle of those two. That'll be the first quarter. And sorry, it is not going to be at 0. It's going to be at whatever this number plus your midline. So if there's a D out here, I would do 5 plus D. I add them together. There's not one in this case. It's 0. So 5 plus 0 is just 5. So that would be at 5. All right, and then if you average these two, so pi over 2 plus pi divided by 2, that's 3 pi over 2 divided by 2, which is 3 pi over 4. That's your third quartile, if you will. 3 pi over 4, and it will be this number, the opposite of this number, plus the midline. So if this number is 5, and let's say this had been 2, then I would do negative 5 plus 2. Right? But this isn't anything. This is just 0. So it's negative 5 plus 0, which is negative 5. All right. So there are the 5 points that this is talking about, and we're after the x coordinates. Is the one that the x coordinates only are what this problem is asking for. So the period of sine 2x, the x values for the 5 key points are 0, pi over 4, pi over 2, 3 pi over 4, and pi. And for whatever reason, it's not letting me check on. But that is, oh, sorry, I accidentally put one right there. The period of this is pi. So those are the points that we're after. Let's do a similar question just to make sure we have it. This is now 3 sine 4x. All right. So if I graph now 3 sine 4x, right? Instead of 2x, now it's 4x. We get through one complete revolution in pi over 2 radians. So we go, at pi, we go through a whole nother one. So the period here is just pi over 2. All right, again, it's 2 pi divided by the number in front of x. So 2 pi divided by 4 is pi over 2. And then the points are 0 again. All right, this number at the end will be 0 plus the period. So that's going to be pi over 2. All right, if I average those two, I'll get the point in the middle, the x3, that'll be pi over 4. Halfway between these two would be pi over 8. And then halfway between pi over 4 and pi over 2 is 3 pi over 8. And that's how we do these quarter period point problems.